Welcome to Keys Precalculus. This is section 4.4. I'm going to review the definition of reference angles and how to find them like we did in class, and then we're going to work a couple of examples. Don't forget that if you've got theta as an angle in a standard position, that means its initial side is on the x-axis going in the right direction and its terminal side lands somewhere on the xy axis. Theta's reference angle is the acute angle, theta prime, that's formed by the terminal side of theta and the horizontal axis. So, in other words, this orange theta prime right here is the reference angle to the red theta, which is in standard position. If theta's terminal side lands in the second quadrant, then the reference angle will be in the second quadrant, and you find it by taking this total 180 degrees, or pi, and then you take away whatever theta was, and what's left over is the reference angle. If theta lands in the third quadrant, the way you find the reference angle is you take all of theta, so this whole thing right here, and you subtract 180 degrees from it, or pi from it, and you're left with just the reference angle. And if theta lands in the fourth quadrant, then you would take the entire graph, the entire circle. So you would take all of this 2 pi, and you would subtract whatever theta is from all that, and what's left over here is your reference angle. So either 360 minus theta or 2 pi minus theta will give you the reference angle if your theta happens to land in the fourth quadrant. Now, if theta lands in the first quadrant, either theta is the reference angle if it is between 0 and 90 degrees, and then they would just be equivalent and you wouldn't have to figure anything, or if theta was greater than 360 degrees or greater than 2 pi, then you would take all of theta, which is this blue angle here, this whole thing, and then you would subtract 2 pi, or 360, from the whole thing, and you're left with the reference angle, what's left over. So let's work a couple of examples finding reference angles. So let's say theta equals 300 degrees. Well, that means because it's between 270 and 360, it would land in the fourth quadrant. So all we would have to do to find theta prime is to take, because this is in degrees, we'll say 360 degrees minus whatever theta is, 300, and we get 60 degrees. See how simple that is? So let's say theta is 2.3. Well, this is obviously in radians, and 2.3 is between pi, which is 3.14, and half of pi, which is 1.57. So we know that it has to land in the second quadrant. So in order to find the reference angle for 2.3, or theta prime, then what we're going to do is we're going to take pi, because it's in radians, and we're going to subtract 2.3 from it. And if you get out your handy-dandy calculator and you say pi minus 2.3, you're going to get approximately 0.8416 on your calculator. Now let's see if we can find the reference angle when theta equals negative 135 degrees. So that means that we are going in the negative direction to land right here in the third quadrant. But we need to figure out what negative 135 degrees is coterminal with when theta is positive. So the way we do that is we take 360 degrees minus 135 degrees, and we get 225 degrees. So we see that this theta here is coterminal with this other green theta here if we were to go in the positive direction. So we're going to use this number, 225 degrees, to figure out what the reference angle is, or what theta prime is. So we're going to, and since we know that it's in the third quadrant, then we know that we have to take the number 225, or I should say 225 degrees, and we're going to subtract, because we're in degrees now, we're going to subtract 180 from it. And when we do that, we get 45 degrees. So the reference angle for negative 135 degrees is 45 degrees. Reference angles will be positive. We're not talking about direction with these. So what's the point? Well, the point is that we can use reference angles to evaluate trigonometric functions. So let's consider the point xy on the terminal side of theta, like we see in this picture here. We know that the sine of theta is y over the radius. We know that the cosine of theta is x over the radius, and we know the tangent of theta is y over x. But if we were to drop an altitude from xy, the point xy, down to the horizontal axis, then that gives us a right triangle. And here we have our reference angle of theta prime in that right triangle. We know that this distance here along this leg of the right triangle is x. And we know that this distance here along this right triangle is y. Therefore, we can say the sine of theta prime is equivalent to the opposite over hypotenuse, which is the absolute value of y, because we know that lengths are going to be positive, over the radius, because r is our hypotenuse. Or we could say the cosine of theta prime is equivalent to the absolute value of x over the radius, or adjacent over hypotenuse. And we could say that tangent of theta prime is equivalent to the absolute value of y over the absolute value of x, because we know that tangent is opposite over adjacent. So basically what this is showing us is that theta prime, I'll write it right here, is equal to theta, except in sign. Or rather, I should say, except not necessarily in sign. They're going to be equal numbers, but they may or may not be equal signs. The sign of the function is dependent on the quadrant that theta lands in. If it's in quadrant 1, then all 6 functions are positive. If it's in quadrant 2, then sine and cosecant are positive, but cosine, tangent, secant, and cotangent are negative. If it's in quadrant 3, then sine and cosine are negative, tangent's positive, and their reciprocals are equivalent. And then if it's in the 4th quadrant, you've got positive cosine, but sine and tangent are negative. Now that we know that, we can evaluate trig functions that are greater than pi, or greater than actually any acute angle, not just pi, but pi over 2, by using reference angles. So for example, let's say we wanted to find the cosine of 4 pi over 3. Well, we know that 4 pi over 3 is greater than pi, but less than 3 pi over 2. So we know that it's going to have to land here in the 3rd quadrant. And this is our pi, or excuse me, this is our theta right here. But that's a huge angle, and we don't have it necessarily memorized. So what we can do is see if we can find the reference angle, or the cosine of the reference angle, theta prime. So first we find theta prime, which, because it's in the 3rd quadrant, we're going to take 4 pi over 3, and we're going to subtract pi from it. So I'm going to write that as 3 pi over 3, because that's the same thing as just regular pi. And then we get 1 pi over 3. So my reference angle is pi over 3. We also see that it lands in the third quadrant. And in the third quadrant, we see that cosine is negative. So we could say that the cosine of 4 pi over 3 is equivalent to the negative cosine of pi over 3. Because remember, theta, the functions of theta are equivalent to the functions of theta prime, just not necessarily in sine. And the cosine, the negative cosine of pi over 3 is going to be negative 1/2 because the cosine of pi over 3 is positive 1/2. So it's easy to evaluate thetas or angles that are larger than 90 degrees by using reference angles. Now let's see if we can find the tangent of negative 210 degrees, which is not an acute angle. And it's easier, a little bit easier because we're working in degrees. So since negative 210 degrees goes in the negative direction, we need to find its coterminal angle in the positive direction. So we can just say 360 minus 210, or negative 210 plus 360 degrees. And when we do that, we get 150 degrees. And we know that 150 degrees lies in the second quadrant. So this will be my theta prime. And the way that we find a reference angle in the second quadrant is we take 180 degrees and we subtract theta from it. But we're not going to subtract a negative 210, we're going to subtract its coterminal angle of 150. So basically we're saying 180 minus 150, which gives us 30 degrees. Now, we are looking in the second quadrant, and so tangent is negative in the second quadrant. So taking the tangent of negative 210 degrees is the same thing as taking the negative tangent of 30 degrees. And we know that the tangent of 30 is the square root of 3 over 3, and we're going to take the negative of that because we're taking the negative tangent. So the tangent of negative 210 degrees is negative square root of 3 over 3. And we found that by using coterminal angles and reference angles. Let's do one last example. Let's find the cosecant of 11 pi over 4, which we know is definitely not acute. We need to find 11 pi over 4's coterminal angle because it's also not only is it bigger than pi over 2, it's bigger than 2 pi. We know that 4 goes into 11 twice with 3 left over. Therefore, the cosecant of 11 pi over 4 is the same thing as saying the cosecant of 2 pi plus 3 pi over 4. In other words, I can go around 2 pi times and 3 pi over 4 more times to land in the second quadrant here. That is theta, and because theta is 11 pi over 4, it is equivalent to 3 pi over 4. So I can say if I take the cosecant of 11 pi over 4, this is still the same thing as saying taking the cosecant of 3 pi over 4, because I can take the cosecant of its terminal angle, or its coterminal angle, and get the same thing. But it's still not acute. So I'm going to have to find its reference angle. The reference angle is in the second quadrant right here, theta prime. So I'm going to say pi minus 3 pi over 4, which gives me 1 pi over 4, or just pi over 4. Cosecant is the reciprocal of sine, and in the second quadrant, sine is positive. Therefore, it's the same thing as saying taking the cosecant of the positive cosecant of pi over 4. So taking the cosecant of 11 pi over 4 is the same thing as taking the positive cosecant of pi over 4, which is the same thing as taking 1 over the sine of pi over 4. And we know that the sine of pi over 4 is the square root of 2 over 2, therefore its reciprocal is simply the square root of 2. So the cosecant of 11 pi over 4 is equivalent to the cosecant of pi over 4, which is the square root of 2. And we found that by using coterminal angles and reference angles. Now let's do a couple of trig identity problems using reference angles, and then we'll be done. Okay, so on the bottom of page 282, example 6 tells us, let theta be an angle in quadrant 2 such that theta is equal to 1/3. Find the cosine of theta by using trigonometric identities. Now we know by the Pythagorean identities that sine squared theta plus cosine squared theta equals 1. So if sine theta is 1/3, then cosine squared theta would be 1/3. Excuse me. If sine theta is 1/3, then sine squared theta is 1/3 squared. Plus cosine theta equals 1. Sorry about that. So this becomes 1/9 plus cosine theta equals 1. If I subtract 1/9 from both sides, then I get cosine theta, got my theta there, equals 1 minus 1/9, which is 9/9 minus 1/9, which is 8/9. But I don't want to know what cosine squared of theta is. I want to know what cosine of theta is. So I take the square root of both sides, and I get cosine of theta is the 2 squared roots of 2 over 3. But do I take the positive or the negative? Well, by reference angle, it tells me it's in quadrant 2, so that means cosine has to be negative. Therefore, the cosine of this theta is negative square root of 2 over 2. Oops, I mean negative 2 square root of 2 over 3. Sorry about that. Try number 68 on page 285. It gives us the cotangent of theta is negative 3, says it lands in quadrant 2 and asks us to find the sine of theta with the information that we're given. Now, there's nothing that directly relates cotangent to sine in the identities that we found, except we can relate cotangent to cosecant using a Pythagorean identity. And cosecant is the reciprocal of sine. So let's do that. We'll say cosecant squared is equivalent to 1 plus cotangent squared theta. So that is the same as saying 1 plus negative 3 squared, which gives me 1 plus 9, which is equal to 10. But I want the square root, so cosecant squared, or cosecant theta, is equivalent to the square root of 10. I need to decide if I'm taking the positive or negative, but in the second quadrant, we know that sine, and therefore cosecant is positive, so I'm taking the positive square root of 10 of cosecant. But I want to know what the sine of theta is. So sine of theta is equivalent to 1 over the cosecant of theta. Therefore, it's equivalent to 1 over the square root of 10, which simplifies to being the square root of 10 over 10. So sine of theta is the square root of 10 over 10 when the cotangent of theta is negative 3 in quadrant 2. So hopefully these examples of using reference angles to find the functions of theta and using identities can help you with your homework.